latitude, longitude. And when you click on a link of that format, it automatically pops up the Google Maps application and shows you that location. So we can actually do the same thing with our application. We can register ourselves for the NetHack protocol, and then the page on the server side can automatically redirect to a page like NetHack data with some private information that would be the response from the server. So here you can see this is a statically declared activity with an intent filter inside our Android manifest. We're requesting the NetHack scheme, and the host is data, which is just what should be the first section of the like what's the host of the URL. So you can think another example here would be the YouTube app would request would set the scheme to be HTTP, and the host would be youtube.com, and that's why when you click on a link to a YouTube video, it opens in the YouTube app instead of in the web browser. And note that this is actually an activity, although we're using it like a receiver. So this would be something that would happen, we would want to happen completely in the background with no user interaction at all. But the idea behind a data intent filter is for something that does involve user interaction. This is supposed to be, I click on a link in the browser, I click on a telephone number in the browser, I click on a map location, something like that. It's supposed to pop up an activity. So here's the activity that it would pop up. In this case, after that page on the server redirects, it would go to it would launch this activity with an intent that contains the data that we set on the server. So here we've set a parameter in after we redirect, and then we can just log the intent, and it has the data that we're looking for in that intent. And we call finish in the onCreate event here, and we never display any UI. This happens instantaneously. Nothing is seen by the user when something like this happens. Again, the same caveat that I pointed out before, you probably want to send the user off to another page so when they open their browser, they don't see anything funky. So now what I would like to show you is it working in action. So there's two things. On the top here, this is my Apache server logs. So we can see the last thing was about an hour ago, the last hit that we got on the server. And at the bottom here is actually the logcat output on this phone here. So you can see the screen is on, and if I turn the screen off, after about 5 seconds, we should see, so it's starting an activity here, we can see that. And then up here, we should see, hopefully, yes, there we go. So here we have every 5 seconds, it's going to ping back and forth between the device and the server, and can send any information back and forth along with this. This is an app that's requesting no permissions. If I turn the screen on, you don't see anything on the screen. It's still just the home screen. Stop sending data immediately, and then turn the screen back off, and starting the intent down here. And there we go, the Apache logs. Thank you everybody next door for cheering for me. Yes. So now that I've showed you all the cool things you can do with 0 permissions, Tim is going to show you a bunch of awesome stuff you can do with only 1 permission.
So here's a pretty typical example of how a typical application actually, would write debug data to the system logs. We import the Android util log class. We declare a tag that will prefix the log entries when they go into the system debug log, and we use a relatively simple API to leave traces there. You'll see lots of examples of these and heavy use of it in a lot of code. So on the Android image, there are, well, up until 2.1, there are three different log devices that are actually available. As of Froyo, we've seen the appearance of a 4th log. It's not entirely clear what the split is there yet. but it is available. Devlog events is described in the reference documentation as not the main Logcat debugging facility. These are diagnostic events for system integration or system integrators and not application authors. For the most part, there's nothing interesting there, but we'll see something developers should be aware of in a minute. Devlog radio contains the log output stream for the system radio. Typically, this includes a lot of command stream gibberish that most people don't want to pay any attention to, but there are some interesting events that pop up in there as well. And then devlog main is actually, as I said, it's the main application log. When your typical market downloaded application uses the log facility, this is actually where the output ends up. So the Logcat utility can be used to look at these logs. Typically a phone that's got debugging enabled, you'll just use ADB to look at that when you're working on your app. Now, ability to read logs is gated by the read logs permission. So this is not as fun as some of the zero permission stuff that David was talking about, but it's still kind of interesting. In the case of a phone that's in debug mode, the shell account is granted permission so that you can invoke Logcat over ADB. And you can kind of look at read logs as a permission, which, in some sense, to uneducated user seems like a relatively harmless thing to request access to, but can actually be built on. There's advice in the permission documentation that logs may contain some private information, but should never contain serious private user information. So in order to explore some of the things that might be hanging around out there, we put together a client. It's a relatively simple Android service. It asks for read logs. As implemented, it does ask for internet, although you can imagine putting this together with the NetHack approach that we can probably work around that. It downloads some policies from the server and applies essentially a set of regexes to the logs, extracts some stuff, and sends it back for analysis. So high level, we have a Logcat device, which in this case is just a relatively simple wrapper around the Logcat utility invoked from within an application. We're going to open that device and we're going to set up a line-oriented reader for it. We have a log monitor, which is actually responsible for kind of the primary data processing thread here. We'll pull each log of line output out. We'll match it against the set of filter criteria that we've established. And if something looks interesting, then we'll actually track it for delivery to the server component. And this is written as a service. The service fires up, attaches Logcat devices to all of the available logs on the device. And requests start sticky so that we actually run in the background. So when the activity attached to the service is not available, it'll still be processing output. So there's also a server component here. It's a relatively straightforward set of Rails components. It's essentially responsible for command and control, policy delivery, and processing the data delivered by device. So we're supplying per device policies to devices connecting back. We're receiving logs that meet those policies that the device actually delivers. We've got an interface to explore the output, go through and see what it is that was actually sent out, and some facilities for post-processing specific log data that we're interested in. A little bit about the policies and the approach that we took here. We sort of started out with a set of random keywords, just a few ideas about things that might be going on in the system. We threw in there insert, update, delete. These are things that are going to appear in SQL statements interacting with data providers. We threw out intents. Intents are obviously a pretty core mechanism for triggering interaction across applications and IPC. Content, looking for anything that might be related to content providers. HTTP, looking for things, protocols. You can imagine, a number of things that go on past there. We also picked a couple of interesting, pieces of data to toss around. There's a keyword in there for first name, for last name, pre-picked phone number, things that might get dropped into the UI that we can flush through services and see where things come out. Set up a set of initial expressions, started pushing data through various interfaces, and looking for places that it came out that maybe weren't anticipated. So one of the first things that we noticed, as I mentioned before, in the event log, there's actually something that pops up on Froyo that we hadn't seen before. This appears to me to actually be old code that's typically been disabled, but is actually enabled on Froyo images that have popped up. And there's a hook in the SQLite database driver to actually sample sets of queries based on the runtime performance of those queries. It only logs the first 64 characters of the query, so you're not gonna see the whole thing in here. But it is something the developers should be aware of if you're concatenating statements together, and those statements contain data. They could make their way to places that you didn't actually intend and have no control over. Similarly, there seems to be a similar hook in there for content providers. And here's a case where we actually see a query that was triggered that includes phone number data. Nothing earth-shattering here, but it is worth taking note of and being aware of as a developer. So as I said before, read logs can end up being kind of an alias for other permissions that are declared on the system. So there is a get tasks permission that allows you to query recently running tasks. However, as most of those things are triggered by intents, we can actually scrape that out of the logs and just keep our own state tracking there, and keep our own table of what tasks have been running. There's a dump permission that's not entirely clear what it gates, but we have an idea, and there are actually applications that are intentionally doing this. If an application is terminated by the runtime, then a lot of information about that termination may be logged to the system logs. And if you have read logs permission, you can just scrape it out of there instead of actually asking for the dump permission. There is a permission that gates reading history bookmarks, and this includes basically looking at URL history and looking at what's in the bookmark set. This is in some ways bad news for the NetHack stuff that David was talking about, because it does mean that there's a trail that you could actually see in the demo that he was doing of data that's being sent off device. But it is good news if you have a different goal, and that's to snoop on the history that's been going on here. We see at the top here kind of a core runtime intent logging that's disclosing some information about visited URLs. The browser's not terribly chatty about that. And in another case here, a chattier component that's only on some system images that actually includes full content of query string data that's attached to activities pushed through the browser. So you can see here that you could extract something embarrassing from somebody's searches. Furthermore, there are cases where we find that read logs is equivalent to having read SMS. This varies from system image to system image, but if the debug logs are turned up high enough, then you can actually see components that will log the recipient as well as the content of SMS that's sent out.